well, by my clock, it's 5:48, and I figured I want to keep you all moving, but questions, issues, anything that didn't work the way you hoped and dreamed that it would work? All right. Well, then I'm going to push ahead. I do have a couple of small examples that I will show that sort of put a bunch of this stuff together so you can kind of see. I think sometimes one at a time, you might be wondering, well, how is this going to be useful, or how does it work into a program? And I do have a couple of things, examples to show, and the mini project for this week will also obviously be incorporating all of these things into program strings, so you can actually see how the math functions and the text functions and so on might work together to help each other out. So the next topic is, it's really just one topic: variables and lists. Variables are in the world of computer programming, variables are one-dimensional and lists are two-dimensional. But they are both just containers for information. So they are objects that don't always have the same value, and you can actually control what the value is that they have. So it's usually a two-step process. You need to define the variable or create the variable first, or the list, and then you need to tell that variable or that list what it contains. So it's usually two steps. But once you've created a variable, that variable exists for the entire program. You don't have to recreate it every time you want to use the variable. You can keep reusing a variable over and over and over again. So in terms of the basic variable functions, there's really only 5 of them. But the first step, and this is one of the only places where you have to do this, is that you need to make the variable first. And you don't do that in the main programming window. You do that in the list of blocks. So when you scroll down to variables, which are orange, there's a box, a clickable box right at the top that says make a variable. So you have to create one first for you to then be able to pull it into your program. So if I click on make a variable, it asks for the variable name. Now, the cool thing about variables in Scratch, back when I learned programming, you had a very narrow range of things that you could name variables. They could be letters, they could not be numbers, they couldn't contain symbols, and there couldn't be any spaces in them. In Scratch, because they want this to be as conversational English as possible, you can name variables anything. You could give a whole sentence to name a variable. That might get a little unwieldy, but my advice is always name your lists and your variables something that is descriptive, that you know exactly what it contains. Because you can very easily get into a program, and by the time you're done, you've got 10 or 15 or 20 variables. And if you just name them generic things, you can lose track of which one is containing what. So let's say I'm going to name this variable Wednesday the 22nd. All right, so I'll know that I made that variable today. And then you have two options. One says for all sprites and one says for this sprite only. My advice for the level of programming we're going to be doing is to keep them all at the for all sprites level. There are times where you want to have a variable where the variable name is the same, but each sprite has its own copy of that variable. But I don't think we're going to get into things that complex. And if we do, I can certainly help walk you through that. But oh, we've got somebody's microphone. I don't know who. Oh, Kaylee. Yeah. All right. Little radio in the background there. So in any case, so my advice is just leave it clicked on for all sprites. That way you can use this variable, you can refer to this variable from a different sprite if you want to, and use it kind of across your whole program. And then I click OK. And then you'll notice that in the list here of variable reporters, there's now one that's called Wednesday the 22nd. So that variable now exists. I can now use it in the program and it will show up everywhere. So that's always step one, is define your variable. Then the next couple of things there are two programming blocks that say show and hide variables. And what these do, and I know it's a little hard to see, I'm going to expand this a little bit, but in my actual program, when it's showing, it actually shows up here in the window. So somebody playing this program right now would see that on the screen along with the sprites and everything else. Generally speaking, you don't want to have it display your variable this way. Normally a variable is working in the background and your user doesn't need to see the variables and know what values they have. There are occasionally you might have it where you do want the user to see the value of a variable, and you could do it this way, but you have no control over what this looks like. You can drag it around on the screen, but you can't change its size, you can't change its color, you can't change its font, you can't do anything. So you're kind of stuck with the look of it. So if I need to display the value of a variable to a user, I'll usually create programming that will do that some other way, just so I have more control over what it looks like and so on. But if I want it to show, then I can drag the show variable thing into my program. If I want to hide it, there's a hide variable. And just to demonstrate this, right now it's showing, but if I click on the hide variable, I have to pick which variable, Wednesday the 22nd. Now when I click on this, that variable disappears from my window. If I do the same thing here and say show variable, then it shows back up. Now you may notice, I know it's probably small on your screens, but in the list of variables over here, there's also a checkbox. And I can also make a variable show and hide by clicking that checkbox. So that's kind of a manual way of doing it. If you want, for some reason, your program to have the variable show up and then disappear, you would do it through the programming blocks. All right. So we've created the variable. We know how to control whether the user can see the variable or not. Now what we need to do is actually make the variable mean something. Right now the variable is empty. If I click on the reporter for the variable, that's interesting. It says 4. I'm not sure why it says 4, but because that's test variable. That's why. Let me bring in my Wednesday the 22nd. If I click on it, it just says 0. Because when you create a variable, it's basically empty. It just contains 0. So if we want that variable to now equal something, we're going to use either the set or the change. The set is exactly what it says. It will just tell the variable, you now equal this, and that's it. So I would pull down the list to my Wednesday the 22nd. I'll leave it saying arrow. I'm not sure why it says arrow. So if I execute this command and then go click on my variable now is arrow. So if I took this and I put it back up in one of the joins, when it got to this variable, it wouldn't say Wednesday the 22nd. It wouldn't say 0. It would now say arrow. If I want it to be something else, I just change that. I'll make it bow. Now when I click on this and then click on my variable, the variable now equals bow. It can be text, it can be a number, it can be symbols. That's another difference. You used to have to declare a variable as either being numeric or text-based, and if you tried to put one or the other in the other, your program would crash. Scratch has gotten smarter than that, and you can basically put anything into any variable. The other one, change, this only works if your variable contains numbers. And basically, it's a shortcut for math, for a simple addition or subtraction. Every time that this is clicked, what happens is it will either add or subtract, if you use a negative number, whatever you put in the bubble from your variable. So this is really common to use when you have loops. Maybe you want the loop to happen 10 times or 15 times. You could have a variable called counter. And each time it goes through the loop, it just increases counter by 1. And then maybe you have something else that says if counter equals 15, then do something else. So I'm going to set my variable to 1. And then I'm going to have it change the variable by, I'll say, just to show the result, 5. So right now my variable equals 1. But if I click this box, it should now be 6. Yep. And if I click it again, now it's 11. So every time that change happens, it adds that number to the existing variable value. So that's a really fast way to get a counter. Maybe in a game, you want to have it keep track of the number of turns that have happened or something like that. Again, you could set up a variable, and each time a new turn starts, it just increases that variable by 1. As I said, if you put in a negative number, then the number will decrease, basically adding a negative. So 9, 7, etc., etc. So in terms of variables themselves, that's basically all there is to it. It's a container that you get to decide what goes in the container. So it's a way to store information and then use that information somewhere else in the program in some way. There is a special variable called answer. And this is connected to this programming block that's called ask blank and wait. So this is really key for anytime you want user like text interaction, when you want the user to provide you with some information that then the program can use. So what goes in the ask bubble can be anything, any question, anything you want to frame. So I could say, what's your first name? Question mark. So what'll happen now is when I click on this, the sprite will have a bubble pop up that says, what's your first name? And at the bottom of the screen will be a text entry field. So I'll execute it. It says, what's your first name? Down here at the bottom of the screen, then the user would type in their name, click the check mark, and the question goes away. Now, on its own, that's not so useful because now what happened to that information? Well, right now, that information is stored in this variable called answer. You don't have to create the variable. It always exists. And it will always contain the value of the last question asked. So right now, if I click on answer, it should say David, because that was the last question that was asked. Now, if I want to ask another question, but then also remember that the answer to the first question was David, what I would do right away is create a variable, maybe called first name. And right after they answer the question, I would make first name equal, or I would set first name to answer. And then that will store the answer result in the variable. And then I can go on and ask other questions, because every time a question gets asked, that answer variable gets rewritten. So just be aware of that. But this can be really, really useful for personalizing a game. You can ask the user's name, and then throughout the game, have it use that name to personalize feedback and stuff like that. So questions and answers, those are those two blue boxes. The final chunk of this, and this is the last thing that we're going to go over tonight, and actually really the last thing with Scratch, are lists. And lists are just, it's a variable, but it's a variable that has a number of different positions, slots in it. So that's why we call it two-dimensional. It's got, you can have a whole list, a whole number of independent pieces of information that then you can access by what position they are in the list. You can replace items in the list. You can delete items from the list. You can insert items into the list. So this would be a good thing if you're maybe asking a bunch of information from a user you could put each of the pieces of information in a different location in the list, and then you could pull that information out rather than setting up a whole bunch of different variables. So at its basis, it functions the same as a variable. You need to create the list, you give it a name, leave it for all sprites. Once it's created, I may as well do one here. So I'm going to call this tonight's list. I create it. Now I've got tonight's list. I can show the list. I can hide the list. Oh, let me make sure I get the right one. So I can show tonight's list. I can hide tonight's list. And if you can see, what shows up is not just a single little box, but a whole thing here, which right now says empty because there's nothing in the list. But we can fill that up with things. So you can show it, you can hide it. You can also do that by clicking the checkbox, just like you did with the variable. Then from there, in terms of setting the values, there's a bunch of things you can do. They're all pretty self-explanatory. I can add things to the list. So I could add the word thing to the list. And now you'll see in my list here, position number 1 now is thing. I could put other thing, add that to the list. Now there's 2 things in the list, thing and other thing. Doing the add will always add to the end of the list. So it'll connect things onto the end. If for some reason you want to put something into the middle of the list, you can insert. So in that case, I'll put the word insert here. And maybe I want that to be the second thing in the list. So I want to insert it at the number 2 position. When I click on it, oh, wrong list again. When I click on it, now insert is number 2, and it pushed the other thing to number 3. So that's a way to get things to go into the list. By the way, this is a way to alphabetize information. You can work this out where it goes through and checks each thing and sees if it belongs alphabetically earlier or later, and you can then move it. You can replace items in the list. So you just tell it which item number you want to replace and what you want to replace it with. So I'm going to replace item 2 with the word tuba. So now item 2 says tuba instead of insert. You can delete a single item by telling it which item. So I'm going to delete item 1, delete. Now my list is back down to 2 things and item number 1 disappeared. I can delete the entire list, which basically just wipes it clean so you can start all over again. So all of those sort of together give you control over building your list, putting things into the list at certain places, managing the list. In terms of what's actually in the list, that's really up to you and up to what your program needs. The final little bit of this then are some reporters, kind of the theme for the night. So we have a reporter that will tell you a certain thing in the list. So I don't have an item 3, but if I say item 1 of tonight's list, it'll say now tuba, because that's item 1. You can also get it to tell you where an item is in the list. So in that case, you just type in something that's in the list and tell it which list. And now this should tell me 1, because tuba is number 1 in the list. It can tell you the length of the list, how many items are in there. And then there's a test, a true false, to see whether your list contains a certain something somewhere in it. And that's just a true false. So if it's anywhere in the list, it'll say true. If it's nowhere in the list, it'll say false. So again, if you've had a user type in a bunch of things and you want to see whether they typed in something in particular, you can test it using that conditional. All right, so that's variables and lists. They're just containers for you to be able to put things into. Before I give you another few minutes, let me just kind of demonstrate how this might work, how some of these things might work. So here I've got a little bit of programming. It says when this sprite is clicked, ask what's your name and wait. So the sprite will ask my name. I will type something in. As soon as I hit enter, it will then set this variable, which is called name, to my answer. So now name variable will equal whatever I type in for my answer. Then it's immediately going to ask me a new question. How old are you? And wait. And then there's a new variable that I called age, and it will then set that to equal whatever that second answer is. So I've now recorded two pieces of information into two variables, one called name, one called age. Then I can turn around and construct a sentence using a bunch of joins and those variables to get it to give me a sentence that says hello to me and then tells me how old I am. Like, I really want to be told that. But that's kind of an example of putting this together. So if I execute this and I click on my cat, what's your name? I'll say David. Then I'll say, how old are you? I am 53. And then it comes back and says, hello, David, you are 53 years old. So I took two empty containers. I got some user feedback. I filled those two containers with the two answers. And then I used those two containers to help construct a sentence using joins to sort of personalize the experience here. So in any case, that's just kind of a quick example of how some of these things can then work together to allow a program to be more interactive. And that's really what all this is about, is the interactive piece, is allowing you to have the program rewrite itself and do different things based on input, based on feedback, based on calculations or random numbers, and kind of go from there. All right, so I want to keep us on track here. We're going to do another just 10 minutes, so it's 6:10 on the dot. 6:20 we'll come back. I'm going to talk briefly about the actual Scratch project, and that's really going to be it for the night. So we should be able to be out of here by 6:30. But I just want to give you a little time again while this is all fresh to try a little bit of this out. Bring me any questions you've got. So let's take 10. We'll be back at 6:20, and then we will wrap the evening up. All right? Ready, set, go.